What is quantization error in digital signal processing? Imagine trying to capture the sound of a bird singing or the flicker of a candle flame with a camera. You can't record every tiny detail, but you want the best possible picture or sound. That's similar to what happens in digital signal processing when converting real-world signals into digital data. Today, we're going to explore what quantization error is and why it matters. When signals like sound, light, or electrical voltages are measured, they are continuous. That means they can take any value within a range. To process these signals digitally, we first sample them at specific moments in time. Then, we convert these samples into a set of discrete levels, a process called quantization. Think of it as rounding each measurement to the nearest step in a ladder of fixed heights. But here's the catch. Because the original signal can have any value, and the digital system can only representing certain levels, the actual value might not match exactly. The difference between the real, continuous value and the closest digital level is what we call quantization error. It's like trying to fit a smooth curve into a staircase. The steps can't perfectly match the original. Quantization error is unavoidable because of the limited resolution of the analog to digital converter, which is the device that does this conversion. The more levels it has, the smaller the steps and the less the error. If the converter uses fewer levels, the steps are bigger, and the error becomes more noticeable. This error appears as a kind of noise, often called quantization noise, which can affect the clarity of the digital signal. The size of the quantization error depends on the step size, which is the difference between two adjacent levels. Smaller steps mean less error, but they also requiring more bits to store each sample. For example, a system with 8 bits can representing 256 levels, while a 10-bit system can representing 1024 levels. This increase in levels reduces the error but also increases the data size and processing requirements. Some systems use uniform quantization, where all steps are equal in size. Others use non-uniform quantization, where steps are smaller in some ranges and larger in others. This helps better representing signals that have a wide range of amplitudes, like audio signals, by reducing error where it matters most. Quantization error can cause distortion in the process signal. For instance, in audio recordings, it might produce a faint hissing sound. In control systems, it can lead to inaccuracies in measurements or responses. To minimize these effects, engineers sometimes add a small amount of random noise called dithering before quantization. This makes the error behave more like random noise, which is less noticeable. The quality of the digital signal can be measured by the signal-to-quantization noise ratio. Higher ratios mean less error and clearer signals. Increasing the bit depth improves this ratio, but it also increases the amount of data to store and process. Engineers must find a balance between resolution, data size, and system performance to get the best results. In summary, quantization error is the difference between the original continuous signal and its digital representation. It's a natural part of converting signals from analog to digital, and understanding it helps in designing systems that produce accurate and reliable digital data. Managing this error is key to making digital systems work well in areas like audio, communications, and control systems.